Guess what? Yes, I'm back with the EverReady. Well, I swear the EverReady looks more and more like being the bane of my life. This radio has been haunting my shelves for ages. Actually, if I come to think of it, um, I really started off this whole restoration business by trying to restore the hardest of them all, which is, of course, the EverReady. I mean, had I started with the Motorola, which is, by the way, a very easy radio, comparatively speaking, to restore, and Westinghouse, which is, let's say, medium level difficulty, well, the EverReady is really high level difficulty. I mean, it's small, it's unhandy, it needs special voltages, it needed really a lot of care and repair, and it even needed a new speaker transformer or audio transformer and a new tube socket. I mean, this radio is really not for the faint-hearted and certainly not for beginners. Take my word for it. Okay, so right now I'm at the stage where I'm sort of, let's say, rediscovering how the EverReady is put together and how the connections work and all that. As soon as I know, or let's say I refreshed my mind, how the EverReady is put together and how all the connections are and all that, I'm going to give it a try to start it up. And I'm really curious. How many mistakes do you think I made when I rebuilt this radio? Well, I sure don't know. But being my very first radio chassis I restored, and the fact that it's quite a complicated chassis, well, chances that I made no mistake at all, well, are pretty low. Anyway, let's keep a positive look on it. I am sure that sooner or later I can make the radio function. But it's not going to be as easy as it was with either the Motorola or the Westinghouse. You'll remember if you watched the previous series, and there are quite a few, of the restoration of the EverReady, that it took quite a while to prepare the radio in its entirety. Well, as you can see, the chassis has been refurbished completely. All the parts, and I mean in the case of this radio, I mean really all the passive parts at least, so the transistors and the capacitors have all been changed or replaced, I should say, by completely new components, including this audio transformer, which was shot. The original had a open primary coil. How that came to be, I don't know, but the case is, or the point is, that the original audio coil or audio transformer was broken. So I changed that one too. The tubes, you see, are all original ones. Now, I should actually call this episode or this update not the next installment in the EverReady N3 radio, but also the first live test of the prototype of my Dynobat high voltage battery replacement. Now you remember that if you watch some of my previous series on the Dynobat, I developed a small prototype of a high voltage battery replacement, meaning that by powering a small circuit with two 9-volt batteries, I can replicate the 90 volts that the original EverReady battery must have produced to power this radio. So yeah, it'll be a test to see whether my Dynobat does what I intended it to do. Okay, so don't mind too much the jumble you see right now. As I said, it's still just a prototype. If it turns out my Dynobat design works satisfactorily, you remember one of my goals is to be able to power this radio chassis at least for an hour with two 9-volt batteries, and I also made a low voltage, so close to 1.5 volts filament battery. Actually, I used 4 AA batteries, nickel cadmium batteries, which I fully recharged, and although the battery cover says they produce 700 milliampere hours and 1.2 volts, it turns out that fully loaded they produce about 1.33 volts, which is more than enough because the original battery the original EverReady filament battery will probably never have produced more than 1.5 volts, and in fact I think those early type D battery type batteries probably only produced around 1.3, 1.4 volts. So that's a perfect substitute for the original EverReady filament battery. So those are fully charged up too. The two 9-volt batteries are fully charged up. I tested it shortly before this video, and they output around 93 volts, which is okay since once I hook it up to the radio, the voltage will probably drop by a few volts. So, well, I hooked up the speaker, the original speaker, to the EverReady chassis, and the original antenna coils you can see there, which are really nothing but very, very thin copper wire coiled in roughly a rectangular shape and glued onto paper, which in turn is stuck to the back of one of the inner covers of the case or the cabinet, with just plain ordinary old-fashioned sticky tape. I didn't take off that sticky tape yet, you see it here, because I didn't want to damage the coils. But I think in the end I will take it off once I put the radio together again. And I'll probably try to use something a little bit better, marginally better, than that old-fashioned ugly sticky tape. As you can hear, there's faint crackling coming from the speaker. So one conclusion that we can already make is that the amplification stage of the radio probably works. However, when I tune the radio, or at least I try to tune it, I don't seem to be getting any radio station. Only that same faint crackling. Now, I'm also trying to feed into the grid of the detection tube a radio frequency signal, just to see if I can sort of wake up the radio. But until now, I have very little success. So except for the faint crackling, which proves to me that the Dynobat seems to work, and the filament battery too, as well as the amplification stage of the radio. Well, it proves that it sort of works, but not entirely. So now comes the tedious process of trying to find where there might be a possible error in the chassis. Maybe I made a mistake. It's quite possible. And since it's the first chassis I've repaired in many years, I mean the very first since at least 20 years ago, it's quite possible, and in fact I can imagine having made quite a few mistakes. Well, if I say quite a few, at least one or two mistakes, which is likely. So, like I said, right now I'm at the stage of debugging the chassis. Hopefully the error will be easy to find. If not, you might be in for yet another few episodes of the EverReady N3 saga. So that's where I stand right now. I hope you enjoyed this combined update of the EverReady N3 and the Dynobat. I intend to make a separate Dynobat series soon, because I want to build it into a nicer case, and also I want to see if I can build an automatic wake up and shut down mechanism for the Dynobat, which would be nice because now I'm using a tiny switch to switch the Dynobat on or off. But obviously it would be nicer if that was an automatic process. I know it can be done, but I'll have to think about it. Oh, for those who are interested to know about that sort of detail too, as you can see, the high voltage pins is or connector is a 3-pin connector which feeds in technically 90 volts into the B+ circuitry of the radio. The other connector is a double-poled connector, so it has only 2 pins, a fat one and a skinny or thin pin. The thin pin is for the plus filament voltage, the fat pin is for the negative or the ground of the 1.5 volts. On this connector, if you look at the 3 pins from, let's say, above or on the side, you'll see that the left pin seen from the center pin is the B+ voltage and the right pin is the ground. The center pin doesn't seem to be doing anything. It's not connected to anything, and I doubt it was connected originally. So I think the center pin's function is really to connect the connector to the battery in the right position, and that's it. So that's where I stand. As you can see, I'm feeding in a 400 Hertz signal into the amplification stage. And the amplification of the radio is really satisfactory. So, well, as I concluded in one of the other updates, the problem is most probably not in the amplification stage, nor in the power supply, but really in the high frequency part of the radio.